All right, so we are live. Hello, everybody. Um, Welcome here to our webinar about satellite image annotation. So I wanted to share, sound and put some music while we're waiting for the first people to come. Sleeping Satellite from Tasmin Archer. Music related to our topic today. So we're just gonna wait maybe 2 more minutes until 35 before launching the webinar. So as you can see, we're the 4 of us here with Lison and Jeff. Just so you know, do you have some sound or don't you? Do you hear the music? One hears the music. Okay, well, I don't know how it works. I shared the sound of my computer, but it doesn't seem to be working there. Anyway, we registered the webinar on Monday because Jeff is actually right now in Louisiana, and with some storms and maybe some internet connection issues, so we decided to record it beforehand, so we don't have any problem right now for the diffusion of the webinar. So we will play the recording we did, and of course after the recording there will be some time for some questions, and we'll be there to answer all the questions. So feel free to ask all the questions you might have during the talk on the conversation side, and we will answer them at the end. So we can now start with this webinar, Isahit Talk number 5, about satellite image annotation for key items recognition. And as said, we're going to introduce ourselves and start with short presentation of the companies. So Lison, if you want to have the talk.
Thanks, Aymeric. Hello, everyone. My name is Lison Leonetti, and I am product manager for One Atlas at Airbus Defence and Space. Thank you.
Hello, everyone. So my name is Jeff Faudi. I also work with Lison and Airbus, and I specifically work on extracting information from satellite images with deep learning.
Hi, everyone. I'm Séraphin Gaborit, and I'm in charge of the customer success team at Isahit.
And I am Aymeric Chevreux, and I'm business developer at Isahit, responsible for this webinar. So now let's continue with presentation of companies of Airbus and Isahit, so you can have a better view of the context and why we started this collaboration. So Lison, if you want to talk about Airbus.
Okay, so let's get started a little bit with our company. So you're probably familiar with Airbus for its plane, but maybe not for the spatial activities. So within Airbus, you have different entities, helicopters. We also do manufacture helicopters, commercial aircraft, which is more famous, but also defense and space products. So within defense and space, there is another entity called Connected Intelligence, and within this entity, intelligence, which is where we work with Jeff. So we will introduce you what we are doing in this company. Basically operate a fleet satellites, optical and radar satellites. So you have an example of the satellites we operate One Atlas, which are a cloud-based platform for accessing satellite imagery. So our satellite, as you can see, we have spot and Pleiades imagery, which are optical sensors, and they acquire imaging ranging from 1.5 meter resolution for spot and 50 centimeter resolution for Pleiades. And we have also another fleet of satellite, Vision 1, which is an optical sensor. TerraSARIX, this time is a radar sensor, which is very useful to see through the clouds, which is not possible with optical. And last but not least, we have Pleiades Neo, which is going to be integrated very soon, and it's a 30 centimeter satellite and optical. So these sensors rated within One Atlas, which is our platform that you can see now in the snapshot. So the ambition of One Atlas behind really to democratize the access to satellite imagery. You're probably familiar with services like Google Maps. Actually, satellite imagery is widely used in the world for many different use cases, especially used to solve challenges in the region of economic problematics, but also environmental, defense and securities, and food supplies, just to name a few examples. And so what is great with satellite imagery is that today, thanks to artificial intelligence, we can automatically detect objects and changes between satellite images. So this is what we are going to talk about today.
Great, thank you very much, Lison. So I'm going to introduce Isahit. Isahit, we are an impact sourcing platform for digital tasks. So our goal is to help companies outsource all the simple and repetitive digital tasks that are doable manually on a computer, such as data labeling for computer vision, but also video subtitling, text labeling for chatbots, online web searches, online moderation. You get the idea. And we use all this project to give work to young women in developing countries in order to help them achieve the life goals. So we are present in more than 37 countries with a community of 1,700 hitters. And we have among 250 customers, big companies such as Airbus or L'Oréal or Sodexo, but also small ones and startups in our clients. So this is how we work. We take the work for the companies, give them to the eaters, and help them achieve the life goals and train them on the digital. So during all the presentation, here are some testimonials from some of the eaters of our community, Miangali and Jackie from Madagascar and from Cameroon. So we are very close to our community, and we have an whole team at Isahit dedicated to the community, to hiring of the community, following, training them, and help them develop their own projects. So we will now continue with the Airbus use case. If you have any question during all this webinar, please feel free to ask them in the chat below. We will answer them at the end of the talk. And now let's talk about Airbus use case. And Jeff, word on you.
Yes. So what you see on the screen is typically satellite images of 30 centimeter or 50 centimeter. And what Lison didn't mention is we got customer in across the board on very different vertical markets. I mean, there will be some people interested in oil and gas, who want to find the oil storage tanks, people interested in roads and buildings, other people that want to look at the cars or trains or trucks. So definitely there's plenty of information to extract from the images. And this up to recently has been done manually. People will use their own eyes to look at the image and annotate what is on the image. And we've been able recently to do that fully automatically through deep learning. And I don't know if you're very familiar with the way we actually create a deep learning algorithm, but we usually start with a large data set. I mean, we know we have to have a lot of imagery. Then we select the best deep learning model to fit our needs. We then have to train it on GPUs. And what we also do is we also then very precisely monitor the accuracy of the model. Okay, and usually we do that with the experts. So we actually check that we achieved the goal that was planned with the algorithm. And if all that is ready, we push that as a Docker file on our system. So by doing that, we've been doing that for almost 5 years now, and we know that we have to iterate either on training, we have to iterate on the GPUs, we have to iterate on the architecture. Okay, and what we know is that typically the model, we can rely on the scientific literature. I mean, there's plenty of model up there. We actually rely on what we can find as state-of-the-art model. And for the GPU training, we usually also rely on the cloud. So we use one of the big like Azure, Microsoft or Amazon or Google. We use this cloud. So what is left to us is actually the data set. So we need the data set for the training, and we need the data set for the qualification. So recently we've been able to open this data set to our client base. So we also selling this data set so that our clients can train their own models, and so they can then tune the algorithm to their own specific needs. So we're interested and think that we can do globally over the surface of the earth, in all countries, all the weather conditions. But some of course, most of our clients will want to do something very locally. So what they could do, they could actually buy data sets from us, and then they can tune it to their specific needs. What we guarantee when we deliver the data set is that the algorithm that you can train with the data set is already very, very powerful. So in this example, for example, that's an example of wind turbines. And we already guarantee that the detection rate will be over 90%, and the precision rate will be over 80%. So detection rate is the number of objects that have been detected, and precision rate is the number of false alarms. So we don't get too much false alarm. At the same time, we detect almost all the wind turbines. So starting from this point, it's very easy then to create a better algorithm suits to the need of the specific customer. We've done that with Isahit. These are data set that we've created with Isahit. So we've done the wind turbine data set. We also work on an aircraft data set, and this one includes different categories. So we can also detect not only the object, but also the categories. And then in that case, we got 80% detection rate and 90% precision rate. So it's all dependent on the type of object. And lastly, the other one that we worked on is the one for vehicles. And again, you can see, the landscape is very different between Middle East, for example, and the North American environment. But we also have this huge data set that is annotated with 80,000 vehicles on Pleiad imagery. And that allows to get a good detection rate, at least a good starting point for a super good algorithm. So if I move to the reason for the partnership and how we meet with Isahit. Well, the idea for us was, when we started working on this topic, we first turned to the expert. We wanted to ask the expert to annotate the data. But as you know, experts are very, very important people, and they're not available. So we can just ask them some help to write some instruction to annotate and get some their ideas on some specific cases. But most of the case, we cannot touch with the expert. Then definitely we have data scientists in our team, and it's interesting that these data scientists actually annotate some of the data, that they understand the data and understand the difficulties inside the data. Okay, like aircraft can be very similar or they can be very different. You have to understand all that. So it's not completely stupid that data scientists annotate some of the data, but what is completely useless is actually that they annotate all the data. Okay, so definitely when you need to have like 80,000 vehicles, you don't want your data scientists to do that. So that's why we turn to externalize company that could actually externalize the annotation. And if you externalize with, classical company, you then rely on a few people, like 1, 2, 3 people, and they're here all the time. But usually your needs actually are going to go up and down. So sometimes you will need like 10, 20 people, and sometimes you only need 1. And so that's why we turn also to crowd externalization, where we can actually have a pool of workforce that we can actually task depending on our needs. Okay, so that is super good actually for us to enable fast annotation of large quantity of data. But the drawback that comes with that is that there's usually inconsistencies between the people, and then we need definitely to work on the quality and make sure that we got a very good quality control that is in place. So with that in our head, we wanted to find a company that could help us. And there's something in Airbus called the Biz Lab, which is now called the Innovation X, which is actually a center for innovation. And there we met other people inside Airbus which had the same needs. Okay, some people to annotate video, and some of the part of the business were doing different things, but we all come to the conclusion that we needed crowdsourcing. At the same time, there was also the issue that if we rely on crowdsourcing with companies that we don't know, they might not behave correctly with their workforce. So, I mean, we wanted to make sure that we were paying a good price to the work that was done, and that all this was done in an ethical way, so that Airbus could not be implied in, so that no people can say that we were doing something that was not ethically correct. So BizLab put us in contact with Isahit. We started the first project with them with the support of BizLab, and then we started working directly with Isahit thanks to the introduction. So globally, as a conclusion, what the partnership enabled us to do was definitely to reduce the price per annotation, to annotate faster, so we can get the result quicker, and we can do the training loops more quickly. So we don't want to wait like 1 month between 2 annotation tasks. We can do that quicker. At the same time, we wanted to guarantee the quality. Okay, and finally, we were confident that we were doing something good for the world, and make sure that we were doing that in an ethical way. And that's what Isahit will talk about now.
Thank you, Jeff. And so, yeah, as you said, at Isahit, we have a specific focus on the impact and the impact we are generating on our community of workers. So basically, what is the impact generated thanks to this collaboration between Isahit and Airbus? So we have 3 different topics on this impact. The first one is the digital skills that the hitters earn thanks to these projects. Then they also earn self-confidence thanks to the work they processed and thanks to the skills they are earning. And then last but not least, as you know, they are paid and they earn money thanks to their projects, and we'll see how much money do they earn on this work. So basically, the first one, on Isahit, on our platform, we developed a digital academy which allows our workers to get new skills. As an example, in 2020, our hitters earn between 6 to 12 skills on our platform. We have some really generic skills, such as how to work on Google Sheets, how to work on Google Documents, but also how to create your own LinkedIn account, which is really useful for them, so as to be at ease on their professional life. And then, as Jeff explains, we need to ensure high quality to our customers, and that's why we have some dedicated training session to our LabLink tool, as you can see on the screen. And on this training session, we are explaining, okay, how to use the tool, what are the important points for our customers, and we have some tests so as to measure their understanding on this training session. This is the first point of our impact. And then our hitters are also earning self-confidence thanks to their work on the platform. As an example, 71% of our hitters accomplished their projects after they left Isahit. So they found their studies or they found a full-time job in their own country. Then 1,500 hitters have been supported since the creation of Isahit in 2017. So it means they received at least 1 payment after they've worked on the platform. And then 96% of the hitters told us to be more confident to look to their future after 2 payments. All these metrics are coming from our KIMSO report, which is a cabinet who is measuring the impact generated by Isahit on our community. And then, as I told you before, they are working for money, and on the projects we manage with Airbus, 55 hitters worked on the projects for a total of 866 hours of work. So it means they worked in average 15 hours per person, and thanks to this work, they earn a little bit less than 50 euros for 15 hours of work. You just have to compare these amounts with the average local minimum income where Isahit operates. So basically, at the moment, where Isahit operates, the minimum income is about 66 euros per month for a part-time job. So they earn 66 euros per month for 80 hours a month. And here on this project managed with Airbus, they've earned 50 euros per heater only for 15 hours of work. And thanks to this work and thanks to our platform and thanks to our customers, we are able to generate impact to our community and to help them to finance and to fund their life projects. And then let's finish with a short demo of Airbus tool, and we'll just play a quick video.
Thank you. So here in this demo, you see the One Atlas interface. So this is what we've seen at the beginning, right? And right now we are going to show you how these data sets that we did with Isahit are transformed into products into our platform. So now we are going to show you an example of analytics, which are basically services allowing to automatically detect objects on the platform. So here we are doing truck detection. If you remember, this is a data set, vehicles, that we worked on with Isahit. And in this example, we are taking an image from May 2018, and it detected a small number of trucks, 263. Now, what is interesting is to compare with the later image. So this image is captured a year after. And here you can see that the number of trucks is much higher, 1,600. And so this is the trucks detection algorithm over a border. So this can be really useful for many applications, defense and security, but not only, it can be used for humanitarian purpose to verify the transportation of foods or supplies and so on. It can be also used for economical reasons. In this other example, now we are in Marrakesh, a beautiful city in Morocco, where there is a concept of Medina, which is an area in the city center where vehicles are not allowed to be present. So this type of detection algorithm can be useful for the municipalities to verify that the Medina is actually respecting this regulation. And here you can see that there are very, very low number of vehicles detected over the area. So these are two examples, but you can imagine many more. Jeff showed you the wind turbines, but also the aircraft detection. To bounce back on the first thing I said about the One Atlas platform, that we want to democratize the access to this data is really to facilitate the implementation of these use cases and to solve this type of challenges thanks to artificial intelligence.
Well, I hope you enjoyed the talk, that you found some answers to the question you might had. So we're all going to come back on the video and on sound, and of course we are going to answer the question if you have some. So feel free to ask all the questions you might have, and we will try to answer them, to explain it the best we can. And to help you better understand the use case and the collaboration between Airbus and Isahit. So, all right. Well, in any way, that was kind of interesting for us to work together and to discover how we could make a collaboration between Airbus and Isahit. The satellite annotation use case is quite particular. We are used to work on computer vision, but satellite images are still always really interesting and a bit tough to work on because it can be super precise annotation to do. But it was very interesting for us, and I don't know if you guys want to share things about the presentation or about our collaboration. Waiting for the question if people have some. Okay, so
No, I mean, this is Jeff talking, that definitely, I mean, writing the instruction and making sure that the annotator know exactly what they're asked to do, and make sure that we can check the quality was very important for us. I mean, we always write instruction, but I know that you've written the instruction also with them. You discuss with them, you talk, make sure that they understand really what was expected, and we cannot expect them to become image analysts overnight. So I think that's also a learning process, and I think the platform is very well done in that respect, that we can check on the annotation and make sure that if there's something wrong, you can go back to the annotator and tell them how they can improve.
All right. Séraphin, maybe one question. Did you have some feedbacks from the hitters who are working on this project?
Yes, well, to be honest, at the beginning of the collaboration with Airbus, they were not so at ease because it's not so easy to be able to recognize vessels, ships, or to determine what is the type of aircraft that you have on the image. But in fact, after several images processed, and thanks to Jeff's guidelines, they've been able to improve their understanding on the projects and to annotate the vehicles, annotate the aircrafts properly. So I guess they are proud of them because, yeah, at the beginning it was really, really hard, a lot of back and forth and a lot of exchanges with them. But yeah, after a lot of images processed, they become faster and faster and more accurate on the data set. And I guess Jeff also checked it because we have a lot of discussion between Jeff and I. Yeah.
Maybe a question for Jeff and Lison. How fast are you able to use the result of the annotated data to improve your algorithm? How does that work once data is annotated?
Well, it's there's a number of use cases for the data. So we can train the algorithm, we can qualify the algorithm, we can retrain the algorithm. So for us, we implemented a connection between our platform and Isahit platform through the API. So by using the API, we're able to ingest, I would say not almost in real time, but let's say, I mean, in a few days. So the eaters were working on the annotation. Then someone from Isahit was doing the data qualification or the data check. Okay, so and when the data was controlled, then we would see that in the API and we would be able to re-import that into our platform and retrain. So I would say really a matter of days.
Okay, thank you very much. Did we have to do several iterations of labeling to train the algorithm, or one was enough?
So it's always a cycle, as I showed in the slides. We usually train a first algorithm with a first set of annotation. Then we look at the result and see how it behaves, and then we ask for more annotation. So that would be the case, for example, if let's say for aircraft, when we say, okay, there's not enough small aircraft, and then we want more aircraft and small aircraft to be annotated. So we definitely look at the result and then ask for more annotation and then retrain the algorithm. What we expect to see coming, and I think that's also maybe something that Isahit will develop, is that we're able to do that in a more closed loop. So we don't have to wait for 1 week, but we quickly understand that the algorithm needs more data in a specific location, and we're able to say this type of data needs to be annotated. This one it's not useful because we already have captured that into the algorithm, and we don't need this to be re-annotated. So I think we'll see more and more a tighter loop, also thanks to artificial intelligence in the tagging process.
All right. One question maybe more to Séraphin. How is quality control managed at Isahit to ensure that we have good quality on the annotated data?
So first, the quality is ensured thanks to our skill, or the skill qualification with the headers. So as I explained during the webinar, all of our headers have skills, and thanks to these skills, we are able to assign them on the projects. And then we have, during the projects and during the annotation are being processed, we are controlling the tasks and we are controlling the quality. So we have two methods at the moment, so as to control and so as to ensure the quality is the finest one. So the first one is the golden tasks method. So basically, at the beginning of the project, we are processing a certain number of tasks, and then all these tasks that have been already completed are sent and are sent to the headers, and then we are comparing the tasks done by the header, processed by the header, with the one we processed internally at the beginning of the project. And then we are also, for this project, we were using this method. All the tasks that have been processed by someone is reviewed by someone else. And so at the end, we are able to say, okay, this task is correct, and we can validate it and we can send it back to Airbus. This task and this image has not been annotated properly, and so we have to correct it. And these actually are the two methods we are using in our platform to ensure quality.
All right. This is another interesting question, maybe both for Isahit and for Airbus. So what kind of other annotation can you do? Can you do LiDAR annotations? This is for Isahit, but for Airbus, do you use some LiDAR images and some LiDAR annotation for some of your project? Is this something like you are using or you will use in the future? Maybe if Séraphin, if you want to start to answer the question, and then Airbus, you have something to talk about this subject.
Yes, so yeah, at the moment we are working for the computer vision algorithm, so on images and videos, and we are able to manage bounding boxes, so object detection, but also segmentation, or maybe some more technical annotations such as graph and landmarks, etc. And we are also able to annotate text and audios. So at the moment, these are the annotation we are able to process internally on our tool.
Okay, and on Airbus side, is LiDAR something accurate?
Also, I think mostly. Okay, just go ahead, Lison.
Sorry. Yeah, no, we don't have LiDAR images as part of our data portfolio. So far not. We could, but as we don't have this type of data, we don't do it. But we do on radar imagery. So maybe Jeff, if you want to jump in.
Yeah, definitely the radar imagery is something that we want to look into. We started to do some artificial intelligence apply on radar imagery and also on optical and radar imagery together. We didn't need to have like a lot of annotation for now, but maybe that will come, and then we will turn to company like Isahit. It will also be an issue with training because radar images are notoriously difficult to annotate. So we'll need to train the people on this type of imagery. And now what is also coming, I think, is 3D. We got a very high resolution with Pleiad Neo. We're able to create 3D model on the fly. And I think there will be a request for more annotation and more intelligence in the 3D model. So we're looking into doing artificial intelligence on 3D images, trying to recognize what are the facade of the buildings and the top of the buildings or whatever. So I think that will probably come also.
Okay, thank you very much. Next question from Benjamin. So you talked about models that deliver a precision rate of 80% and detection rate of 90%. According to you, what are the maximum reachable rates, and about how many annotated images will be required?
Well, it's really depend on the use case. So there's depending on the object you're looking at, there might be a lot of differences. Some might be small or big. I mean, for example, the cars, they will almost always be the same size all over the world. If you think of aircraft, I mean, some might be very big, some might be very small. If you think of ships, I mean, they might be huge. I mean, there are ships that are like a few hundred meters in length. So depending on the use case, I mean, we achieve different performances. I think that globally we want to be in the area of more than 95% accuracy. This is what is a sort of expectation from our users, and we also think that we want to help the photo interpreters, I mean, the image analysts. So we want to provide them something that is almost, I mean, maybe not as good as them, but almost as good as them. And I think making not seeing 5% of the object on the image is something that is acceptable for them, but more will be difficult to accept. So again, I mean, we're trying to go above 95% to consider that the algorithm is very good.
All right. Another question, so there can be mistakes in data annotation, and how would you deal with them? What if there is a mistake in data input on an annotation to train the algorithm? Or will that influence the learning of the algorithm? And is it possible to correct it so the algorithm resets itself in some way? Or how do you deal with it?
Yeah, definitely. I mean, this is something that is possible. If some annotation are wrong, if there's not too many wrong annotation, the algorithm will learn correctly, and then we will be able to rerun the algorithm on the images and see where there's a discrepancy between the annotation and what is the predicted annotation. Then we can specifically revisit this case and see what is the reason for the discrepancy. It can be that the algorithm has not seen enough objects of this type. It might be also that the annotation is wrong. And that's an interesting point. When the annotation is wrong, we want to correct all of them. So we can either remove all this annotation or we can ask them to be relabeled. And that's usually interesting to know when it was done. So that's where there's an interesting connection between our platform and Isahit platform. Because we want to make sure that, for example, if it's a specific annotator, specific features that has been wrong on some specific image, then we can go back to them. And then that's why we actually need to retain who has been doing the task at what time, maybe at the time it was at the end of the day or whatever. So we can then make sure that we fully recognize all the other annotation that might go wrong, and then we're able to do another pass on the annotation.
All right. Next question, maybe for Séraphin. Have you developed yourself your own web-based annotation tool, or do you use an open source software? And is it complicated to do something ergonomic for sophisticated annotation like 2D segmentation mask or 3D points clouds?
Okay, so at the moment we have integrated the software developed by the CEA, or the CEVA in French, called Pixano, which have some open source tools for annotation, and we are customizing this soft so as to answer our customers' needs. So we are able, thanks to this, to Pixano, but also thanks to our technical team, to manage and to answer to really specific needs on some specific projects. As an example, for Jeff, we developed, and for Airbus, we developed oriented bounding box so as to reduce the noise and so as to give a directional vector for every vehicle annotated. And this is something which was not directly integrated into Pixano. And then if it's something complicated to develop something ergonomic, I guess the
hardest part for this is not to develop something ergonomic, but to develop something which can be used for every single user. So basically on the 3D annotation or 3D point cloud annotation, it's not so easy to move into the space so as to annotate the vehicles or so as to annotate the pedestrians. And I guess it's not the tool, or the tool can be useful so as to help you, but you also have to be focused and to be focused on your task, on your annotation task, so as to annotate properly the objects. And then I guess it's also a challenge because it's a web-based annotation tool. It's a challenge for us, but also for all the companies to have a tool which can be, I'd say that which can be strong enough for huge annotation, for tasks with huge annotations or with heavy data, because it can be sometimes not so not so strong than on-premise tool or software.
All right, thank you. Question for Airbus: what are the next use case you will work on, and will deforestation will be part of it?
Deforestation is definitely something that we're working on. Specifically for deforestation, we've been working with specific company that already provide the ground truth. So they actually have people going on the field and making sure that deforestation is reforestation, if it's legal or illegal. And so we didn't needed to have external annotation. We were able to use ground truth, so coming from different sources. So there's a lot of use cases. I mean, maybe Lison can say more about some of the things that we're working on. We do not always have to rely on crowdsourcing for annotation.
All right. Maybe last question, because we're reaching out of time. For a specific project, is it possible to work with heaters spread all over the world with very different backgrounds to avoid potential bias in annotation? That's a super interesting question and subject we're working on. Séraphin, if you want to answer the question.
Yeah, so basically for all of our projects, our heaters are not living in the same country. Basically, first, we are using this method because if you have some, I don't know, electrical issues or internet issues in the country, the project can continue. But for the bias in annotation, I have two main examples, two use cases. Like in food recognition, we are working with a huge company in France, and they asked us to annotate food trays. Yeah, this is it. Thank you. And they have to spot and to recognize the food in the trays. So depending if you are living in South America or depending if you are living in Europe, it's not the same food, and you are not so at ease so as to recognize the food. So thanks to the people living in South America, Africa, or Southeast Asia, and in Europe too, we are able to limit this bias, but also to ensure high quality in the annotation. And then we were working on a project where we have to annotate landmarks on faces and on selfies. And every single selfies was processed by 12 different people coming from Africa, coming from South America, or coming from Southeast Asia with different ages, different. So yeah, thanks to this and thanks to our diversity in our community, we are able, in fact, to avoid the bias in the annotation and to determine the consensus in the annotation that we are delivering to our customers.
All right. Well, we're running out both time and question, which is quite perfect. So thank you very much for your interest in the topic we discussed today, for coming over. We will send a replay of the webinar that will be available on our YouTube channel, as well as a short resume of 5 minutes of the highlights of the session. Thank you so much, Jeff and Lison, for your time and participation in this webinar. We were super happy to to do this talk with you and with Airbus. So long live our collaboration. And thank you all, and see you for the next Isahit Talk in October. Have a good day.
Thank you.
Goodbye.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Goodbye.
Yeah.